All right, in this next video, still with the product rule, right? We talked about what it is, how we can use it if we're given two functions. But sometimes we have to use the product rule when we have this mixture of explicit functions like 4x, e to the x, sine x, and implicit functions like f of x, which we don't know what it is, but it's a function. We have to find the derivative. So I want to do example 7. Remember, when they're asking us to find a specific value, take the derivative first and then plug in the value. Don't plug in the value at the beginning. So we're going to find the derivative of k. The derivative of k is, well, there are two functions being multiplied, 3 sine x and f of x. So we're going to have to use the product rule. The product rule says take the derivative of the first times the second. I think my computer's getting tired. It's not capturing the color that I want. There you go. Plus, take the derivative of the second times the first. This is what I need to do. Now let's do it. So we're still finding the derivative here, right? The derivative of 3 sine of x. Well, 3 is a constant, so I'm going to hold it, times sine of x. The derivative of sine x is cosine x. Times the f of x that was already there as part of the formula. Plus f prime of x, which again we don't know, but the derivative of f is f prime, and then times 3 sine x. I'm actually going to write this 3. We usually write constants in the front, and front as coefficients, I guess I should say, to the left of the function. So I'm going to write it there, 3 f prime of x times sine of x. Great. Now I found my derivative formula, my derivative function. Now I can find my derivative value by plugging in a 0. So this is 3 cosine 0 times f of 0 plus 3 f prime of 0 times sine of 0. That's a lot of zeros. Great. I'm going to zoom in. Let's see if we can find some of these fairly quickly. 3 times the cosine of 0, if you think of the unit circle, if you use your finger trick, whatever you use, cosine of 0 is 1 times f of 0. Well, f of 0, they gave us a table here. When my input is 0, f is negative 4. So this is going to be negative 4 plus 3 times f prime of 0. So I go back to my table. When x is 0, my input is 0, my derivative is 5. When x equals 0, my derivative is 5. So I come back over here and I say, all right, well, that's 5 times the sine of 0. And if you think of the unit circle again, sine of 0 is 0. This is what I need to evaluate in order to get my derivative value at x equals 0. If I multiply this, I get negative 12. If I multiply this, I get 0. So therefore, my answer is negative 12. I had to do the product rule because I was multiplying two different functions, 3 sine x times f of x. But even though I didn't know what f of x was, I was able to find the eventual values because they gave me a table here to use. And that's something that certainly I wouldn't put past them in trying to ask you to find derivatives that way. Another way they're going to ask you to find derivatives would be through a graph. Again, different ways to do it. I'm actually going to do example number 11, but let's see what it says. Another k of x function. 2 minus, here's a product. So I got to use the product rule with this times this. Got to find the derivative first. K prime. Let me erase that. K prime is equal to the derivative of 2. Well, that's 0. Minus. I'm going to have to do the product rule, but remember, we're subtracting it. So whatever we get, we have to subtract. And that would be the derivative of the first times the second plus the derivative of the second times the first. This is what I need to do. But remember, I'm subtracting these things. So whatever I get here, I'm going to put the opposite or minus in front of it, and I'm going to put a minus in front of this as well. So let's see what we get. The derivative of this is 3x squared times g of x minus g prime of x times x to the third. And now all we have to do is substitute our x value, and we will be home. Yay! Let's see. F prime of 3. That's negative 3 times 3 squared times g of 3, whatever that is. We're going to have to look at the graph, minus g prime of 3. Again, we're going to have to look at the graph, times 3 to the third. See how we have a mixture of explicit equations? In other words, equations where I can plug in the number and I know what it is, right? I can calculate that. Versus implicit equations where it just tells me, or maybe I shouldn't say implicit, but maybe unnamed equations, just g of x, but I don't know what it is. But they should give me something, either a table or a graph, something that I can use to get my answer. Let's see. So let's find g of 3 first. I'm going to go to my graph, g of 3. When x equals 3, g is negative 1. Let me pop out that point with a bright color here. When x equals 3, my g value, my function value, my y value is negative 1. So that means this is negative 1. So when I multiply negative 3 times negative 1, I get positive 3 times 3 squared, which is 9. That's going to give me 27. Or you can say negative 3 times 9 is negative 27 times negative 1. That would be positive 27. That works as well. When I come over here, I need to find g prime of 3. Now I'm looking for the slope at x equals 3. Oh, I did it again. No. I really do think my computer's getting tired here. So this will be the last example we do. So I need to find the slope at 3. Well, the slope would be the slope of the line here. Do you see how my computer is getting tired? Because I chose green, but it made it black. So let's try it again. Let's see if it chooses green. Yay! What is the slope at that point at x equals 3? It's just a flat line, so the slope is 0. So that makes it easy because that means this whole thing is going to be 0, and 0 times anything is 0. So therefore, our answer is 27. I kind of like these because it kind of keeps your mind going like, is it this, is it this, is it this? And then I have something like this. We're going to do this problem, examples 13 and 14, on the next video.